This is a demonstration of Autodesk Inventor's iLogic module, working with Excel to read and write to Excel. So I've got a shed here with some panels on the front and on the right hand side. The left is on the front panel is offset to the left of the door. It's 1850 by 900, and I think this one's about 1500. So if we turn the panels off, you can see that we've got all these frames using top hat sections, C channel, and a couple of little flashings and things like that as well. So I'll just go back to the default view, and I'm going to open up the Excel spreadsheet and make some changes. So I'll just go ahead and make some changes. We'll go everything to the max. I don't want a door this time on the left hand side. I want one on the right. And maybe want it 2200 by 1800, and I only want a small door on the right hand side. So I'll just close that, and we'll run the rule. It's just asking me to save changes to the Excel spreadsheet. It's now reading the spreadsheet. It's doing two things. It's reading the spreadsheet, and it's going to write to the spreadsheet. I want to produce a quote from this as well. So it's taking some properties from the assembly file and writing to Excel as well, which will be the second prompt to save the spreadsheet. So we want to change that, and it says the right door width exceeds the maximum parameters that I've allowed in there, and it's just going to be adjusted to the maximum width allowed for this particular shed size. So and same thing with the front panel door. Yet again, I've got some rules in there. So it's asked me to enter a door width on the left hand side. I'll just go 1500. So iLogic will drive anything. So we've changed the part file, but you can see the frame hasn't updated. Yet again, I'm just showing you manually how it's all working. I'd click update here. We can set what's called an I trigger to automatically do the update. But like I said, I'm just showing you manually what's happening. So it'll drive anything, any parameter, sheet metal, flat patterns, drawings, bills of materials, the whole lot. I properties, equations. It's pretty extensive what iLogic can do, and if you know some Visual Basic or .NET, you can extend that functionality even further. I'm not an engineer by any stretch of the imagination, and I've done this all myself, just learning basic rules. The good thing about it is you're not constrained to the design, so after it's built, you can go and modify it how you please and customize it. So we're almost there. So there you go. Take the panels off. It's all there. So what I'm going to do is just shut it down, because I want to write a bill of materials from the assembly level to the Excel spreadsheet, and this is the way I've got to do it without writing a script or doing it from the drawing level. So just asking to save. Let's just open the shed again. I'm going to export the bill of materials, parts. We're just going to delete the old file or overwrite it. So it's exporting the bill of materials to an Excel file, which is linked to the shed form that I've created. So I'll just open the shed form now. It's going to update to talk to the two spreadsheets. And if I go to the quote, we've got the part number populated from the assembly file, the description, and a couple of other iProperties that I've blended together. So 10 by 6 by 4, 10 by 6 by 4, and we've got a quote there as well, all dynamically done within iLogic. Let's put the right level of detail on. Shed panels back on. Thank you.